Hey students, today's lesson is on scale drawings. So let's start with some vocabulary. A scale drawing is a proportional, two-dimensional drawing of an object. So it could be smaller than the actual object or larger than the actual object, but it needs to be proportional. So any change that you make is made to everything on that drawing. A scale model is a proportional three-dimensional model of an object. So it might be something that you build out of clay or cardboard or something like that that represents a real three-dimensional object. The scale is the ratio that compares the measurements of the drawing or model with the actual measurements. So just like any other ratio, it can be written in fraction form where 1 inch is to 10 miles. 1 inch on the drawing represents 10 miles in real life, or it can be written as a ratio with a colon in between. 1 inch is to 10 miles. So in our first example, we're going to find the actual distance, we're going to use D to designate distance, between the two cities of Cadillac and Detroit. So look at the map on your sheet as well, and Detroit is kind of over here in the bottom right-hand corner, right here. And then Cadillac is up here kind of in the middle of the state of Michigan. So you're going to use your ruler and measure in centimeters the distance between those two cities. And it should be 3.5 centimeters if you're measuring that. So 3.5 centimeters. And we're going to use this scale that they tell us here. 1 centimeter equals 50 miles. So we're going to write the scale, which is that ratio comparing the actual amount to the map amount. So that scale is 1 centimeter to 50 miles. And then we know that on the map, that distance is 3.5 centimeters, and we're trying to figure out how far it is in real life, so D miles. So we use this ratio, that's the scale, to set up a proportion. And we know how to solve proportions. We're going to use cross products here, so D times 1 is D equals 50 times 3.5. D equals 175. So our answer is 175 miles. Let's look at another example. Here we have the liquid outer core of Earth is 2,300 kilometers thick. A scale model of the layers of the Earth has a scale of 1 inch to 500 kilometers. So every inch on the model represents 500 kilometers in real life. So we want to figure out how thick is the liquid outer core of the model. So we have the scale of 1 inch to 500 kilometers. So let's set that up as our ratio. 1 inch over 500 kilometers. And this time we have the real measurement. We know how large this is on the actual Earth. So that's going to be 2,300 kilometers. And what we're trying to find is X inches. We're trying to figure out how big that is in the model. So again, we're going to solve this proportion. We'll use cross products. So 500x equals 2,300. We'll divide both sides by 500, and we get x equals 4.6. So we were solving for inches, so our answer is 4.6 inches. All right, time for one more vocabulary word, and that is the scale factor. So a scale factor is really just a scale without units. And what I mean by that is that the units are the same. So in our last example, we were comparing inches on the scale to kilometers in real life. If we're doing a scale factor, we're comparing inches to inches or kilometers to kilometers. So because we're using the same units, you're basically saying how much bigger or how much smaller something is in real life. So let's look at this example where it says a scale model of the Sergeant Floyd Museum is 10 inches tall. The actual monument is 100 feet tall. So part A is, what is the scale of the model? So the scale is going to be the model height over the actual height. So that's the scale, and they tell us that every 10 inches, or the 10-inch monument equals 100 feet. So 10 inches is the same as 100 feet. Now, I can simplify this scale by dividing by 10. So every 1 inch on the model represents 10 feet in real life. So 1 inch to 10 feet. Part B, we're going to find the scale factor. So that means we need to be using the same units. So it'll make sense to use inches in this case. So we'll start with the scale, which is 1 inch to 10 feet. And then we're going to rewrite the feet in terms of inches. So that means 1 inch equals 120 inches, because every foot is 12 inches. So 10 times 12 is 120. So scale factors, we know, does not have units. So we'll just cross off the units here, and we'll say it's 1 to 120. And sometimes it's also written like this, 1 to 120. So what that's telling us is that in real life, the actual monument is 120 times larger than the model. All right, one more example. Here we have a scale drawing of a computer chip. So in real life, this computer chip is teeny tiny, but the scale drawing is bigger so that we can see some details. So we're going to find the perimeter and the area of the computer chip in the drawing, and then we're going to find the actual perimeter and area of the computer chip. So we can see that we have this centimeter ruler here, which is blown up so that we can see it, but it should be approximately accurate on your paper. And we can see that in the drawing, this is 4 centimeters long. And I believe it's a square. They don't tell us that, but this is a square. So it's 4 centimeters on every side. So the perimeter on the drawing is 4 centimeters times 4 sides. 4 plus 4 plus 4 plus 4, or 4 times 4. So the perimeter equals 16 centimeters. The area is going to be also 4 times 4, but for a different reason. Length times width. So that's 4 times 4. So our area is 16 square centimeters. Okay, so our perimeter is 16 linear centimeters. Our area is 16 square centimeters. Now, let's find the actual perimeter and area using our scale that we're given. So we're told that 1 centimeter in the picture is equal to 2 millimeters in real life. So we're going to set up the scale of 1 centimeter to 2 millimeters. And we know that in the picture, the length is 4 centimeters. So we don't even need to use cross products to solve this. We're multiplying by 4. So that means it's 8 millimeters long in actual life. Okay? So our perimeter is a different color, so it's not all blurring together here. Our perimeter would be 8 times 4. 4 sides that are each 8 millimeters long. So that's 32 millimeters, linear millimeters. And then our area is going to be 8 millimeters times 8 millimeters. So that's 8 times 8. So our area is 64 square millimeters. All right, go ahead and try a few on your own. I will see you soon.